All right. Sorry. Where are we at? Who did I skip over? You? Yes?
Just help in one of the bathroom ones.
Do what?
Section 2.3. Page 1.3, following section.
87. Oh. The funny thing about 87, the funny thing about it is when you read it, you're like, holy shit. But then if you look below it, they set it up for you. So 87 says, so they show you this picture. A jogger at first runs 5 miles an hour for T hours. So they put all that on that for you. They're really nice to you on this problem. At first they run 5 miles an hour for a while, so they have a little jogger person. Yay! And then they start to run at 8 miles an hour, right? That's the reverse of what I would do. I'd start off at 5 miles an hour and then slowly. For the rest of the time. Now this is interesting. If I said I ran for a total of 1.1 hours, stay with me now. If I ran for a total of 1.1 hours, you with me? And the first leg of it I ran for T hours, how long did I run for the second leg of it? Well, if I ran 0.3 hours here, how long would I be running for the second part of it if I ran a total of 1.1 hours? If this was 0.3, how long would this be?
0.8.
0.8. Why? Because it's got to add to 1.1, right? So 1.1 minus 0.3 would be how much left? What if it was 0.4? This would be 0.7. That's crazy because 1.1 minus 0.4 is 0.7. So how much did I run? T. So what must this be? 1.1 minus T. That's what you'll always do. I just don't know what T is. If T was 0.3, I would do that. If T was 0.4, I'll do that. So I'll do that for whatever the hell T is. I'll do that. Anytime you have a total. If I knew there were a total of 80 people at a concert, and there were X men, I like it. How many women were there then? If there are 10 men, how many women? 80 minus X. If there were 10 men, there would be 80 minus 10 women. If there were 20 men, there would be 80 minus 20 women. If there's X men, there's 80 minus X women. A total minus one of them is the other one. That's how totals work. That's all algebra is trying to tell us right there. So if they ran for T hours here, they must have run for 1.1 minus T there, so overall it was 1.1 hours total. So they set that up for you already, because they knew that was a little bit weird. And they ran for a total of 7 miles. So how far did they get here? How far did they go here? What's distance formula?
7 miles.
No. Total was 7, so how much was just this one? You don't need anything. You've got it all right there. Yeah, T equals what? RT. What's the rate? How fast are they going? 5 miles an hour. For how long? Yes, we do. T hours. So if you were going 5 miles an hour for 5 miles an hour for 3 hours, how far would you go? 5 miles an hour for 3 hours. 15 miles. What do you always do? Whatever number I put in there for the time, what are you going to do? 5 times that. Aren't you?
Yeah.
So see how algebra sets up a rule to use something we don't even know yet. That's the power. The power of algebra. Is I don't know shit, but I can still do something with it. Even if I don't know it, I pretend like I know it. It's T. There it is. So what do? Whatever it is, I'm going to multiply by 5. So how far did they make it here? 5T. Plus, how far did they make it here?
8.8.
Yeah, 8 times. For how long?
1.1 minus 2.
And that's got to equal what? Got to equal what? 7. Because the total distance they went was 7. So the distance from this piece plus the distance from this piece must be the total distance they went. 7. And then all you got to do now is solve it. So they did all the hard part for you, to be honest. This kind of stuff is the hard part. Then you just got to piece together, well, if I want distance, I got to do rate times time. That's distance. So rate times time, bam. Rate times time, bam. add those two distances together, they got to make 7 total.
Okay.
And then now you solve it. Okay, you distribute, you solve it. That should be the easy step. Yeah.
I have a question.
Anybody else have one on this here? You have a different one? Real quick. She was first. Go ahead.
Number 27 on 2-4. So I just wanted to, I think I set it up right, but I got the wrong answer, so I don't know what to do.
Oh, all right. So 27 has got this triangle with a
At least I got it.
square on it, right? So this is 73, and this is 52 all the way around. It's a square. So they want to know the total area of this. Well, this is, I will say, area of the square. What's the area of the square going to be?
Side by side.
So it'll be
52 by 52.
52 times 52, whatever the hell that is, right? 26 so forth.
I got 7.
704. That was close, right? Is that cool? And again, whenever they give you a picture, if you can see shapes you know, you attack those. And then the whole area is going to be the sum of those. So what's the area of this triangle?
73 by 52.
Yeah, how tall is it?
Minus half.
Not minus half.
Divided by 2.
Yeah, 1/2 base times height. So 1/2, 73 times 52. So they don't label this, but they know it's a freaking square. So I know that's 52, right? So take that area and
Together.
add them to get the whole area. I like it. Yes, sir. Real quick, who's next? What's up?
On the practice test.
Yeah. Do I have any left? Yeah.
Yeah.
Which one? Sorry.
4 F. 4 Fred.
For Fred. Oh yeah. Which Fred? I have two. I like the letter F. I guess. And you're like, don't like the letter F, Jeff. Let go of that.
The equality.
Okay. The inequality.
The
Equality. The first F. Okay. Gotcha. All right, so let's see. So the first 4F. I've loaded this down with so many common mistakes. All right, why do I do that? Because I have to.
This is F in the first.
Yeah. No, from the practice test. Yeah. The first 4F. So what do I do first? Good. And the numbers I'm distributing are both negative. So I get 2 minus 6
Plus Z.
plus
Oh, 3Z.
3Z. All right, let me stop there. Is that cool? So that's the first common mistake you got to plow through. That's a negative. It's got to come with it. Is that cool?
Yeah.
Okay. Plus Z, right? So that's another mistake people forget this poor little dude. So that's this, and then that's there. Equals 5
Minus 4 plus Z.
plus
Z. 4Z.
4Z. All right. Let me stop there. How are you doing so far?
Good.
So this kind of problem, you should just go, oh, yes, thank God. Give me a lot of these, Jeff. This should be the nice part. All right, if you don't agree with me, you got to come see me. You got to let me help you get through it. But this should be the nice part right now. This should be like, oh, yes, please, Jeff, give me more of these. You don't have to say it all like that. I'm sorry. That's what you- You'd be like, Jeff, you can just give me nothing. I'd be happy. Blank sheet of paper with an A on it. No. So now what's the next thing I do?
4.
2 minus 6.
Who do what?
Minus 4.
Negative 4.
Plus 3Z. No, plus
4.
4Z.
4Z. I like it. Z. I like it.
Equal 1 plus 4Z.
Yeah, that's crazy. 1 plus 4Z. That's awesome. I like it.
Negative 1 here. sign.
Sure, okay. So you could do subtract 1, sure. And then what do you got to do? What do you got to do? You got to
Divide
get your
4.
z's together.
Yeah.
No,
Subtract 4z.
Yes.
divide 4?
No.
No?
Subtract.
You don't divide until the very end, because that's people are trying to divide too early. You get all confused. You could divide right now, but then you would make fractions when you don't really need to. Why would you do that to yourself? Divide at the end almost always. What do you do? How do you get the numbers by themselves? You get rid of 4z, so you got to subtract 4z. And you get negative 5 equals
0.
0.
What?
Which means what?
No solution.
Beautiful. So don't circle this business. I know this. You don't have to prove this to me. Explain what that means. No solution.
No solution.
This is not true, so therefore it's no solution. Yeah.
So even though I got it wrong, I put negative 4 equals 1, 4.
No, so if you didn't do this, then you would get negative 4 equals 1. It's still, is that true? Ever?
No.
Okay, so I put no solution.
You're fine. No solution. That's the right answer. I don't care what you have before. If you put the numbers together or not, you still get not a true thing.
Okay.
Never true, so it's no solution. Yes.
Number 3, Jay.
Oh, okay. So this is a...
Sorry, he's before me. Sorry.
What happened?
He's
Where?
before me.
Sorry.
He
Go ahead.
asked you before me.
Sure.
Yeah.
Yes, okay. Section 2.4, question number 9. Yes, very nice.
Ooh, I like it. All right.
Hello, Richard.
So this is a... what's that? No tricks. There are no tricks. Circumference of a circle. And they ask you to find the radius and the area, right? They tell you this is true, and they ask you to find the radius and the area. What's the formula for the circumference of a circle?
2 pi r square.
No.
2 pi is r. Yeah.
Why is it not square? Because it's not an area.
Yeah.
Area is squares.
Yeah,
Little
right.
squares fill an area. Circumference is a single dimension, believe it or not. It's not covering something, it's going around something. That's a length, not squares. So how do you do this then? Well, what do you know? What do they tell you?
C.
C is...
2 pi.
Alright, so instead of C, I write something better.
2 pi.
I write what it is.
2 pi equal 2 pi r.
I know that looks weird, but how do you solve for R? How do you get R by itself? They want to know what the radius is, so I got to
Divide.
solve for R.
Divide 2 r.
Divide by,
Divide
no,
to R.
subtract. Divide.
2 pi.
Why do I divide?
Because it's the opposite of what's going on.
Yeah, it's multiplying right now. I have to divide. Subtraction cannot cancel multiplication. I've said that on way too many papers. So some of you guys are like, yeah, I remember that. Subtraction can never cancel multiplication. So you can't subtract. If you have 2x equals 7, you can't say minus 2 just because it makes the numbers nice. Right? You can't. I'm sorry. Subtraction can't do that much. It's not its job. It can't do that. It's not my job. So here I get what? Radius is?
1.
1. So that's the first part. And then they ask you for the area. What's the formula for the area? Now bring in your stuff. Pi r squared. And how do you figure out this? Well, you know the radius is 1. So
Pi 1 by 1 square.
you get pi. The radius of that would be pi. So if you have a circumference of a circle is 2 pi, the radius is...
R squared.
What? So what's the radius?
1.
1. So what's the area?
Pi by 1 square.
Pi is 314. So
No, stop.
3.14.
No, please do
Pi.
that.
Yeah. Pi.
Pi. Pi is not 3.14. It's not. You guys with me? You guys understand what I mean? Pi is not 3.14. It isn't. 3.14 is a reasonable approximation for pi. But what is it about? Why did we give pi a symbol? If it was 3.14, we'd just say 3.14. But the reason we gave pi a symbol is because it's huge. It never ends. It's the biggest damn thing. It just goes forever. And it doesn't repeat. There's no pattern to it. Irrational. Thank you. Whoever said it. Okay, cool. So be careful. I know. Don't believe that pi equals 3.14. Why have you used that before? Because pi is way too long to use the whole thing, so we just approximate it with 3.14. They are not equal to each other. Is that cool? If any teacher told you that, you find them and slap them. Right.
says, that's whatever.
Yes, so, okay, so you can see this by approximately 3.14. That's, that little wavy equals is like, it's about 3.14.
That's fine.
Sure. If they say to use that approximation, that's fine. But don't tell me that they're equal to each other.
No, 3J.
Oh, you were next, right?
Yeah.
Oh, this one, yeah.
Yeah, just that last part. What happened to the 1 squared part?
Yeah, what is 1 squared?
1 times 1.
Yeah, so 1 times pi is pi.
Okay.
Cool.
Gotcha.
If it was 2, it'd be 4 pi, right? Cool.
Yeah.
But it just doesn't show up because I don't write the 1, yeah.
Okay. 3J. Yeah. And,
Oh, that's right, okay. So this is an exercise in like terms, right?
yeah.
Give myself some more room here.
I have problem with x squared. I didn't understand.
So 3j looks like this. Oops, minus 1. Okay, that same problem here. Yes, good. 3j is this, right?
Yeah.
Okay. So what's the first thing I do?
2 by.
Yeah, distribute.
6x. Oh, yeah. This is what.
No equals, because you said equals.
Oh, sorry.
I'm so picky, but come on.
Okay. It's simple now.
Now it's easy, right?
Yeah.
What are you able to put together? 2y goes with negative y, so I get
Y.
y. What else goes together?
6x.
This goes with
square with 4x squared.
this guy.
Uh,
So I get minus.
plus.
No plus.
Oh,
You owe
yeah,
this
yeah,
guy
yeah,
$6,
yeah.
you owe that guy $4. Unfortunately, they don't cancel. Now, real quick, I see way too many people tell me this. I know I'm not done. This guy is by himself without me right. This is not right. This is not right. Don't write that down. Do you see any x to the 4th in there?
No.
So how do you see 10 of them? I don't see any of them. What do you see 10 of? Negative 10 of, but still. What do you see 10 of? X squares. What's the only time exponents can change? What are exponents based on? Multiplication. So they only change when you multiply or divide. When you add, you change the coefficient. You're keeping track of how many of these things you got. So I saw that kind of thing way too often. There was a problem in the homework that was like that or something. And way too many people were telling me that. I'm like,
Why did I add a
I don't know. What's up?
I put a divided sign next to, or instead of the plus sign, so I...
Oh shit, that makes it a lot harder. I didn't mean that. Yeah, sorry.
7 on the practice. 7, 8.
Oh yeah, the psychic hotline, yeah. Must be, was it Diana Ross that was doing this? The psychic hotline?
Y minus 10x plus 3x.
10x squared, right?
Yeah, I had y minus 10x squared over 3x. I don't know why, but plus 3x.
Yeah, because there's plus 3x is all by itself. All by himself. Got nobody to go with, poor little dude. He might like it that way, I don't know. 7a. The cost to call the psychic hotline is $4.50 first minute. And $3 for each additional minute. So just to make sure everybody understands, if I called and talked to them for 2 minutes, how much would I have to pay?
4.5, 4.50 plus 6 plus 3.
times 3?
You pay $4.50 for the first minute,
Then
plus
3.
$3 for 1 additional minute, so
yeah.
$7.50. You guys with me? So what if I talk for 3 minutes?
Uh-oh. Yep, I did.
What if I talk for 3? So for 2 minutes, it's $4.50 plus
9.
3 times 1, right? What about if it was 3 minutes? It'd be $4.50 for the first minute plus how many additional minutes did you talk for?
750?
How many additional minutes did you talk for?
X.
If it's 3 minutes,
2x?
2 extra minutes, so it'll be 3 times
X.
2.
X.
Why are you guys going with There's 3 minutes. There's nothing I don't know. Where's this shit coming from, Jeff? Where are you getting this shit from? I'm just making sure I understand the problem. So before I do the algebra, which is difficult, working backwards, I don't know how many minutes, right? I'm going to say, what if I did know how many minutes? Could I even handle that? If I can't handle that, I probably can't handle the algebra. So if I talk for 2 minutes, it's 450 plus 1 3, right? Because it's 3 for every additional. If I talk for 3 minutes, that's 450 plus $2 $3, right? Because it's 2 additional minutes. So now let me get, if I talk for X additional minutes, let me do it like that. X additional minutes. So it'll be 450 plus 3X. I like it. Now some of you guys could do like X minutes, and this would be X minus 1. It's up to you. If I do it like this, will X be my answer? The X means what? Additional minutes, right?
Yes.
So, whatever, if I get X equals 7, that's not the right answer because I'm not counting the 1 minute here, am I? So I got to add 1 at the end. What's up?
I just put 3750 minus 450 over 3.
Not good enough. Sorry. Thanks for playing. We didn't use any algebra. And I understand that there are more than one way to solve these problems because we want to make the problem easy so that it's not the problem itself. It's the algebra that you're getting used to.
Okay.
You've got to use algebra or else you're going to lose almost all, if not all, the points. Right? Why do you have to do that? Because it's in the title of the class. It's algebra class. So I'd say 450 plus 3x equals 3750. I want to use all my money. I want to know how long I can talk to these people. So everything you just did will happen to solve this equation. So the point of that is not to make you say, well, what good is algebra if there's another way to do it? We're getting used to algebra, so when you hit a problem that's impossible to do in your head, algebra steps in and says, hey, good thing you know me. I'm going to make this shit easy. Yes?
Can I just put an X in front of it and say X equals?
No. No, you didn't use algebra to solve it. This is using algebra to solve it now. You subtract 450, you divide by 3. Exactly what you did. And again, it's so that you can start to trust algebra. If you set the algebra up, it does exactly what you wanted to do, doesn't it? Which, don't look at that like, well, why the hell would I ever do algebra then? Which I understand you guys do. When you get to a situation where there's more variables or there's too much going on, it's impossible to do in your head. But if you set the algebra up, it'll do it for you. So this is just getting used to how algebra works. So that when I hit a problem that's impossible to do in my head, I can do that. I like it. Yes?
Can you do number 87 on 2.5?
No. That's the only... No, I know. Let's see. All right, good. All right.
Not gonna lie, the fraction freaked me out.
Well, the nice thing is you can kill it. First thing. Right? Because it's inside of an inequality. So you got a couple layers of fractions in there, right? All right, so let's do this. Let's do this. When you say that, what do you mean?
So to make everything the same denominator?
No,
No?
not yet. How do I kill this fraction?
Oh, multiply.
Multiply by what?
By reciprocal.
Good. So what's the reciprocal? You guys see that?
2 over.
I want to kill this fraction first, and then to kill this fraction, I can do what you're thinking. Now you could, all day long, you could distribute that if you wanted to,
No.
right? Nothing wrong with that either, especially because what's 1/2 of 4?
2.
Yeah, so see, you don't make another fraction, so there's 2 ways to do this. And I don't know which way you would like better. Let's do this way first, since I've got it up here. How do you do this times this? What happens to the 2's? They cancel, so you get negative 1/3. Is that cool? Plus, what's negative 1/2 times 4?
2. Negative 2.
Negative 2. I like it. All right, is that cool by itself? You can distribute that. Anything sitting in front of something, you can distribute it, whatever the hell it is. So what's up?
So we can now multiply by -3 and change the...
Totally, yeah. You can multiply by -3 if you want to, sure.
Change
Yeah, and since you're multiplying by negative, you got to flip the sign, exactly. Because what do you do to kill this fraction? You multiply by the denominator. It's only one fraction. You guys kind of with me?
Can you finish doing it?
Sure. So when I multiply by, if you want to, we can multiply by negative 3, sure. So I got to multiply both sides by negative 3, right? So what happens to this?
Switches.
Has to switch because I multiply by negative. What happens here?
1x.
Good, 1x. And then here, what's negative 2 times negative 3?
Plus
6.
Alright, so now that should be easy, right?
So when we divide the negative, we change the
Divide or multiply by negative. You must change the symbol. Why? Because it happens. I love that answer. Because that's how numbers work. That's how numbers work.
The 3x.
Positive to negative. So we have.
Whenever you multiply or divide by negative.
The negative 3x?
Yes.
How did you get that one?
So if I multiply this side by negative 3, I better multiply that side by negative 3. So negative 3 times x is negative 3x. If I multiply this side by negative 3, I've got to multiply that side by negative 3.
Oh.
And what's x times negative 3?
Yeah, it's negative 3x.
Negative 3x. Cool. We got to do the same thing to both sides, right?
Oh, okay, because you did it.
And why did we do it here? So I can kill this fraction. That's
So
all.
because you did it there, you had to do it there.
Of course. Anything you do on one side, I got to do the other side, or else I'm out of balance. Right?
Oh, you were using distributive property on that one.
Yeah, so each piece gets a negative 3. The first thing I did was distribute. That's the first thing I did. Now how do you go from here? To be honest, what I would do is I'd add the 3x and subtract the 6, because then I keep my x's positive. Negatives screw me over with these, right? So if I add 3x and subtract 6, I'll get this.
But then the sign stays that way.
Yeah, because I didn't divide or multiply by negative. Yeah.
Okay, I think that's another problem there.
Is that cool?
Yes.
Yes, a little bit? I don't think
Now
I did
divide
that.
4. Divide 4. No.
Yeah, and then divide by 4. X less than or equal to
2
No.
minus
3 over 2.
Yep.
3 by
And then you can graph it, interval notation it. Right? If you graph it,
No, in this one.
which way are you going to shade?
I thought it was just this one.
I'm sorry.
To the left.
Yeah, down. And what you going to put on this
Bracket.
bracket? So what's the interval notation look like? What's the smallest it could be?
Negative.
Yeah, from all the way down up to this. Bam.
Should we do like the oblique circle or the
What do you think?
No.
There you go.
no? But here we do oblique circle.
What do you think?
No.
No.
No, we don't do that.
So not only do we not do circles anymore, because let go of those. Let's be more technical. But also this would be a closed circle because it's allowed to equal it. So if anything, it would be that, but no more. Why do we do this weirdness? Because it relates right to directly with this weirdness. Yeah. Yes.
This is for the problem. This is one question. When something's on the other side of the equal sign, you divide or multiply.
Do it again.
When something's on the other side of the equal sign, you divide or you like.
You have not given me enough information. It totally depends on the operations, right? You do the opposite operation always.
Negative 3x equals 12.
So why is the x not by itself? Why is the x not by itself? That might be a weird question, I don't know. Why is the x not by itself? Because it's multiplying by negative 3. How do I cancel multiplication of negative 3? I do the opposite. Divide. So you can't do this. Please stop. Addition cannot cancel. What is negative 3x plus 3? Negative 3x plus 3. You just put more shit on top of it. That's no good, right? So to kill that negative 3, I got to divide by negative 3.
X equals.
Yeah. And turn the sign there. Hey. Or not, don't worry about it. You always do this, just that symmetric. Okay.
This one?
No, this
Is that cool?
Oh, it was 87.
Yes.
Can you do 60?
Oh yeah, that sounds. So notice I didn't say to solve 6C. I didn't say to solve 6C. 6C. Or A, B, or C. I didn't say solve. A, B, or C. I didn't say solve. Half a number added to. Okay, half a number. What's half a number?
1/2 X.
Oh, it's crazy. Half a number added to.
Plus 2.
Added, just added to, not 2, but added to. Added to is plus. So half a number added to the product of that number and 9. What's the number? What do we choose to be the number? Baby. What's the number? What's the number?
Half X.
No, that's not the number. Half a number. Half a number. So what did I choose the number to be? X. Alright, so half a number added to the product of that number and 9. How do I write the product of that number and 9?
X by 9.
Or better known as 9x.
9x. Yeah.
Half a number added to the product of that number and 9 is
Equals.
3.
3 more than that number.
3 plus X.
That'll work, sure. Or x plus 3, either way. Half a number added to the product of that number 9 is 3 more than that number. Bam. I didn't say you had to solve it. I just said set it up. Oh, Scheisse.
Scheiße.
Scheisse. German for shit.
I know this.